Okay, you know what? So while I'm still angry about day 23, I'm just going to drink some wine as I drink wine out of a mug and try and do problem 24. Why the hell not? Electromagnetic moat. The CPL itself is a large black building surrounded by a bottomless pit. Enormous metal tubes extend outward from the side of the building, intervals and descend into the void. There's no way across, but you need to get inside. No way other than building a bridge out of the magnetic components thrown out nearby. Each component has 2 ports. The ports come in all different types. Only match types can be connected. You take an inventory of the components by their port types. Each port is identified by the number of pins it uses. More pins means a stronger connection. A 3-7 component has a type 3 port on one side, a type 7 port on the other. Your side of the pit is metallic, a perfect surface connected magnetic 0-pin port. So this, the first port you use must be of type 0. It doesn't matter what type of port you end with. Your goal is just to make the bridge as strong as possible. The strength of the bridge is the sum of the port types in each component. For example, if your bridge is made of components 0, 3, 3, 7, and 7, 4, your bridge has a strength of 0 plus 3 plus 3 plus 7 plus 7 plus 4 is 24. Plus you have the following components. With them you can make the following valid bridges. 0, 1, 0, 1, 10, 1. Notice how, as shown by 10, 1, order of ports within a component doesn't matter. However, you may only use each port on a component once. For these bridges, the strongest is 0, 1, 10, 1, 9, 10. The strength of 0, 1, 1, 10, 10, 9, 31. What is the strength of the strongest bridge you can make with the components you have available? So, here's a bunch of components, and let's think about this. And what is this one called? Day 24 moat. Day 24 moat.py. Okay. And this is one of those things where it's going to be greedy, and that's going to be too slow in the long run. And so, I want to so I'm probably going to do tuple from typing import tuple. No, I'll do name tuple because I always do name tuple. And we're going to say, what do we call these? A component has 2 ports. So class component is a named tuple, and let's say port 1 is an int, and port 2 is an int, and necessarily port 1 is less than or equal to port 2. We're just going to construct it that way. And we're going to parse line. Line is a string, and it's going to go to a component, and we're going to say a comma b equals line dot strip dot split on this thing. A equals int a, b equals int b, and return component min a b max a b. And so that should be fine. And now I won't just do this parse, which is a raw as a string, and it's going to be a list of components. And I just want to return parse line for line in raw dot strip new lines dot split on new lines. Okay, and so let's say test input equals this, and let's say test components equals parse test input. And now let's do IPython run day 24 moat. Name list is not defined. Test components. So we got 0, 2, 2, 2, 2, 3, 3, 4, 3, 5, 0, 1, 1, 10, and 9, 10. Actually, do I want the smaller to the... That's... I don't need to do this because that's not going to help me at all. Int A and B. Let's try this again. So, actually, and I'm going to do the following. I'm going to say available is a set of int and used is a set of ints. And I think this will work out better for me. And use equals that. So component available equals int A, int B. I think that will be nicer, but maybe it won't. Okay. So how do I want to do this? Actually, I don't even need used. Let me do this again. Available is a dict from string to int. No, so it's a dict from int to int because that didn't work out for the ones that had two of the same. Available int A equals available.get int A plus 1, and same for int. I could have just done a default dict, but I'm not going to. And so now for like the nth time, let us run this. Name dict is not defined. Get int A, 0. And okay, well that's not good. Return component. You know what? I don't even need a component now. It's just going to be component is a dict from int to int, and return available. Okay, so that's good. And now, what do I want to do? I want to say I want to do something kind of dynamic programming. And how am I going to do that? I'm going to say so I want to say highest score. Is that what I'm trying to find? Strength of the strongest bridge. Okay, so let's say strongest bridge given some components. which is a list of components. And what I want to do is I want to say, let me just look at this thing. Yes, that's totally fine. So we're going to do like a dynamic programming thing. N equals len components. So that's the number of components there are. And then heaviest equals max of component dot keys for component in components, and then cached equals, let's just say none for something in range n plus 1, for something in range heaviest plus 1. And so the idea here is that cached ij is the best you can do if you can only use items from j onward. Items from I onward, and you have to start with weight j. Okay? So, what I want to do is I want to start so that should be fine, and that should be fine as well, because 0 counts in one and not in the other. So what I want to do is I want to say for start item in range n minus 1, minus 1, minus 1. Okay? So earliest item there. And for start weight for initial strength in range heaviest plus 1. Actually, let me do this again. So for, let me just call this 0. So I'll get 0, which is, I'll get that in the last row, which is when I can't use anything. So that will give me a good recursive case. So, what do I need to do now? And now I already dislike, once again, the way I've represented this. I'm just going to say that component is a list of ints, and return int a, int b. Okay, so that's fine, that's fine, that's fine. Okay, so what do I want to do? But I haven't kept track of which ones I've used either, so that's actually not that helpful. Okay, so this dynamic programming way is probably not going to work. So let's just do this naive way and see what happens. And let's just say initial int equals 0. for, let's just say AB for component in components at AB equals components. If A equals initial, then that means we can use that with B. Then let's just say, best equals 0, AB. If A equals initial, best for A equals strongest bridge. Let me do this way. If initial in AB, so that's good. Remaining components equals C for C in components if C is not equal to components. Best for A, and then if A equals initial, best for A, best for A equals best for B equals 0. If A equals initial, best for A equals A plus B plus strongest bridge of remaining components B. If B equals initial, best for B equals A plus B plus strongest bridge remaining components, comma A. And then best equals the max of best, best for A, best for B. And then return best. So, print strongest bridge of test components. And that says 31, which is 31. Okay, good. So, let's get this input now and save as day 24 input.text. Let's change this to an assert strongest bridge test components equals 31. If name equals main with open day 24 input.text as f, raw equals f dot read dot strip new lines, components equals parse raw, and then print strongest bridge from the components. So let's run that and see what happens. And it's not very fast, is it? Because it's doing a lot of ugly recursive work. And so this is where I need to Oh, 1940. Okay, so it did run, and it took a long time, and I bet for part 2 they're going to make me do something where that didn't work. One gold star closer, return to day 24. The bridge you built isn't long enough. You can't jump the rest of the way. An example above, there are 2 longest bridges. Of them, the one that uses the 3-5 component is stronger. Its strength is 0 plus 2 is 19. What is the strength of the longest bridge you can make? If you can make multiple bridges of the longest length, pick the strongest one. Okay. So that's easy enough. So let's just write a longest bridge function. And it should take the exact same amount of time to run. Def longest bridge. So best equals length 0 and weight 0. Okay. So we will call this length and strength. And I think this, if I do like max of length 10, strength 20, length 10, strength 30, and length 9, strength 50, it's going to do what I want. So that's fine. Best strength for A, so let's think about this a little bit. Remaining components is that. So if A equals initial, I'll say BFA length, BFA strength equals equals longest bridge, remaining components A. And let me say BFA equals 0, 0, BFB equals 0, 0, so that'll be fine. And then BFA equals BFA length plus 1, BFA strength plus A plus B. And then similarly, if B equals initial, BFA length, BFA strength, no, this is BFB, sorry. So let me just, so this should take the exact same runtime as the previous one because it's doing the exact same thing. Remaining components with B. No, but I think I got this backwards, right? So I want to do that with B, and I want to do that with A. Although actually, if they're the same, I don't need to do that double work, but whatever. BFB length, BFB strength, and then we'll say BFB equals BFB length plus 1, BFB strength plus A plus B, and then best equals max, best, BFA, BFB, turn best. Let's comment this out. Let's comment this out again. That's fine, actually. Print strongest bridge of test components. Okay, and so let's run that. So why did that not do anything? Because I did print strongest instead of longest. Is 4 and 19. So 4 and 19. So that's good. So now 19. And now I'm not going to print the strongest bridge because that'll take a while. I'm just going to print the longest bridge. It's really cold in here. So longest bridge test components equals 4, 19. And now that'll work. Drink my wine. Wait for the thing to run. Should take exactly as long as the previous one. Really should have gotten rid of the duplicate one. 35, 19, 28. So, 1928. That is the right answer. And I got ranked 536. So that one was not too bad, unlike yesterday. So I feel better about myself now. As usual, you can find me on Twitter at JoelGrus, and I will put this on GitHub. And it didn't take that long. It took only 26 minutes, which is awesome. So now I feel a little bit better about myself. See you next time.